Hi, today we're going to go through the acid and base review, and this is pretty similar to the kinds of questions you would see on the test. So let's jump in. In the first section, just label things as an acid or a base. The property ones are easy because you have those notes, like if something is sticky to touch, that's an acid. If it has an H in the formula, that's an acid. It turns red litmus blue. When something turns blue on litmus paper, you can remember B for blue, B for base. If it has a sour taste, that's an acid. If it has an OH in the formula, that's a base. When you have the numbers here, there's typically two ways to do it. If this were, not a pandemic, you would have to do some converting maybe. But you have, sort of unlimited resources right now. So for me, the easiest thing that we know for acids and bases is the pH scale. If you know the pH scale, you can convert all of these numbers to pH to find out if it's an acid or base. We're on the pH scale. 1 to 7 is an acid, 7 is neutral, and then above 7 is a base. That's the pH scale. So if you converted these to pH, that would be one thing to do. You can also use these number lines. I think I showed you them earlier. I just did the pH scale. You sort of have 4 number lines, and they all work together. So you've got the pH scale, which is acid and base. This would be 0, 7, and 14. So for all of them, for the one below it, it's also 0, 7, and 14. That's the pOH scale, which is the opposite. The pOH scale, this is an acid and this is a base. It's just flipped. Then you have these concentration scales. I don't know if I showed you these yet, but for H plus and OH minus, it's the same idea. If you have a lot of H plus, like 10 to the 0, then you're an acid. 10 to the negative 7th is neutral, and then above 10 to the negative 7th, sorry, below, because it's a smaller number, would be a base, and it's the opposite for the OH scale. So on the OH scale, if you had between 10 to the 0 and 10 to the 7th, that would be a base, and then 10 to the negative 7, 10 to the negative 14 would be an acid. So that's helpful. I mean, if this were regular, I'd make you memorize those, or if you didn't want to memorize those, you could just convert them all to pH. That's a simple thing to do as well. But since I wrote them down, I might as well use them. So this is OH minus is 10 to the negative 4 on the OH minus scale. 10 to the negative 4 is like right in here, and so that's a base. On the H plus scale, we're at 10 to the negative 9th, so the H plus scale smaller than 10 to the negative 7th is here, 10 to the negative 9th, so that's also a base. And on the pOH scale, you've got 1.35, so if we find the pOH scale right here, 1.35 also makes this a base. Okay. Again, if you didn't want to use the scales and number lines, you could certainly just convert them all to pH. That's an easy way to do, which we're going to do later here at the bottom part as well. So for naming acids and bases, you're just using the 3 acid-base naming rules. So if something is hypochlorite, ClO, this would be hypochlorous acid. Has an OH in it, so it's a base, such as calcium hydroxide. Let's see. Has an H in the formula, N is off the periodic table, so you would call this hydrogen nitride, IDE. So we call it hydronitric acid. You've seen this one a bunch of times. It's got this acetate in it, so it's acetic acid. And then when you're doing formula writing, you're probably going to crisscross. So sulfurous acid is sulfite. Sulfite is hydrogen for acid, and sulfite is SO3. It's got a -2 charge, I think. So H2SO3. Formic acid. Oh, now I do need to get my sheet out. So embarrassing to not have the sheet ready. Formic acid would be formate. Hopefully formate's on here. Formate, CHO2, it's got a -1 charge. So HCHO2. When you crisscross it, perchloric acid is perchlorate, which is ClO4. It's got a -1 charge. H is +1, so HClO4. And then hydrocyanic acid, it's the only one on here that would have the hydro prefix because that's cyanide, IDE. You can't even see it. Not good. Cyanide right there. So UV hydrogen is +1, cyanide's -1. You get HCN for your answer. Okay, and then on to the math section here. If you wanted to calculate the quantities requested and label, you could use the pH square. I'm not going to pull the pH square out, but you had an assignment with the pH square on it. That's the easiest thing to use for this. I will write the equation out though. So if you want to get from H plus to OH minus, you use the KW equation. It's the top part of the pH square. So you essentially take, let's see, 1 times 10 to the -14th divided by 2.63 times 10 to the -10th. So 1 times 10 to the -14th divided by 2.63 times 10 to the -10th is 3.8 times 2 to the -5th. And that would be an acid because, oh sorry, be it a base because the OH minus, if you use that, this answer, 10 to the -5th on the OH minus scale up here, you'd see that it would be on the base side. If you have H plus and you want pH, that's like one of the easy ones, right? Just take the negative log. So negative log of 2.7 times 10 to the -3rd. And you get 2.57 for your pH. And so that would also be an acid because the pH is below 7. For labeling acids and bases, we're talking about Bronsted Lowry acid and bases. Remember, acids will lose an H plus, bases will gain an H plus. So if you look here, it says H2O. If you look here, it says H3O. So it gained. So there is the base. HCl became Cl minus. It lost, so it's the acid. And the roles just get reversed on the other side. If it starts here at H3O plus and becomes H2O, it lost, so it's the acid. And Cl minus became HCl, so it's the base. Here, you've got H2O becoming OH minus, so it lost one. So it is the acid. CO3 minus 2 becomes HCO3, so it's the base because it gained, and then the roles just get reversed on the other side. So you've got this one would be the acid, and then this one would be the base. Okay. If we're looking at some of the math problems there at the bottom, like, oh, this is a titration problem. So this is a neutralization problem. The equation for neutralization is number of moles of acid, MbVb equals number of moles of base, MaVa. Gonna need a balanced reaction for this. It's just HBr and NaOH, so it's a 1-to-1 reaction. HBr plus NaOH makes HOH and NaBr. Oops, sorry. So it's all 1-to-1, so you don't need these variables in this equation because they're all 1-to-1. Now you're just going to plug in molarity and volume of base, molarity and volume of acid, and it looks like in this problem we're solving for the concentration of the HBr, that's the acid, so we're solving for this variable right there. So the molarity of the base is 0.15 molar, the volume of the base is 17 milliliters. Volume, we're solving for molarity of the acid. The volume of acid uses 68.5 milliliters. So just divide both sides by 68.5. 0.15 times 17 divided by 68.5. I got 0.037. So molarity of the acid equals 0.037 molar. Ooh, right balance reactions, probably not going to have you do that on the test. It'd be a little aggressive, so let's just table that for now and go on to what I call like the harder pH problems. And the harder pH problems just have a bunch of steps, and you have to remember some things about pH to do them. So in 23, it says calculate the pH of a solution that has 2.8 grams of HCl dissolved in enough water to make 11.4 liters of solution, while pH is equal to the negative log of the concentration of H plus. So we need to find concentration to make this happen. So first I have to convert my 2.18 grams of HCl into moles. The molar mass of HCl is 36.5 grams per mole. So you'd stop there and do that. 36.5. You end up with 0.06, we'll call it, moles. And remember, concentration is moles per liter. And so we get the moles, we had the liters in the problem, so just divide this number by 11.4. And that gives you 0.00524 molar. And that's the molarity of the HCl. But since there's only one H in HCl, then this is also equal to the concentration of H+. You don't need to do anything, you don't need to double it because there's only one H there. You will double it in the next problem because there is a 2 there, but we'll get to that in a second. So now I know H+, the pH is just the negative log of H+, so take the negative log of that number from pH. And I got 2.28. And no label necessary for pH. And then finally, in number 24, you've got a different kind of problem. It's a dilution problem. 750 milliliters of 0.0091 molar solution of barium hydroxide is diluted to 4 liters of water. Calculate the pH of the resulting solution. Well, right off the bat, you got milliliters and liters. So let's just make this 0.75 liters by dividing it by 1,000. That'll make our lives a lot easier. In this problem, we're going to use the M1V1 equals M2V2 equation, and we're going to solve for M2. And that M2 is concentration, and if we want to find pH, again, pH is negative log of H+, so we can get ourselves pretty close with that. So set it up as 0.75 times 0.0091, and put a 4 there and solve for M2. So it'd be 4 liters. So 0.75 times 0.0091 divided by 4. And you're going to get 0.001. 0.0017 molar. Okay. That's for BaOH2. It has the OH in the formula. It has the 2 in there. So you're actually going to want to double this because of that 2 right there. So take this guy and multiply it by 2. And you get 0.0034. And that would be the concentration of the OH minus. Okay, so we doubled it here. And now, because it has the OH in the formula, this is the concentration of OH minus. That's where the 2 comes into play, is right here. And then finally, you want to get this OH minus to be pH. So there's more than one way to do it. The easiest way to do it is take the negative log of this first. So negative log of 0.0034. This will get you the pOH. So that would be 2.46. And go 2.466. And then since this is pOH and you want pH, you just use 14 minus that. And that would get you your pH. So right answer is 11.53 for the pH. If you look at these problems, you're like, where's all the math coming from? I'm using the pH square, which I don't have right now, but that's where the equations come from. And of course, you could use the pH square on your test this week. Okay, this has been fun, everyone. That's a review of acids and bases. This has been a good talk. I look forward to seeing you soon. Take care. Give me a call. Bye.